Welcome back to a mile-high edition of B&G Solves It. Today we're at the U.S. Department of Energy's National Renewable Energy Lab, touring the Energy Systems Integration Facility. This facility is the world's most efficient data center, where waste heat is recovered from the computers and actually used to heat the facility. A state-of-the-art facility like this requires a lot of integration in the construction process. The local Bell & Gossett representative, McNiven Company, was a key player working with the consulting engineer, the contractor, and the owner representatives to make this building work. We're going to hear from all of them today and really learn some fascinating stuff.
There are many Bell & Gossett products on the NREL campus. The majority of the buildings out there incorporate Bell & Gossett pumps, heat exchangers, expansion tanks, and air separators. NREL ESIF was a project that they wanted us to go in and help them find a solution for a basic data center project that would incorporate heating without using chillers, and then spread that heating within the other two portions of the building.
When this building was first laid out, a high-performance computer, a supercomputer, was at the heart of it.
High-performance computing data centers, which is what we do here, have a very high energy density per rack, so about 70 kilowatts per rack. When you get to those high densities, you can't cool them with air anymore, but we can take warm cooling water, 75 degrees or so, run it up to the rack, and then come back with 95 or 100 degree water. We can take that warm water and then do other useful things with it.
We knew that we wanted to capture the heat from the computer in the form of water because it's very easy to transport from one place to the next. So that started to suggest this hydronic system for cooling, and also using use of heat exchangers to transfer that heat and move it to other parts of the building where it can be used usefully.
We set a PUE, power use effectiveness, of 1.06, the best in the world.
That means 1 unit of energy goes to computing, and 6% of that goes to everything else, to cooling the system, to providing fresh air, lighting, energy conversion from grid power to chip power.
And to be able to meet that 1.06 PUE, you have to pay very close attention to everything that uses energy. So any of the pumps, fans, etc., you need to minimize all the non-compute energy.
And I believe Bell & Gossett was a differentiator. We use a lot of Bell & Gossett. We've used them year after year. We have no issues with them. It's reliable, energy efficiency is high. Long-term payback and energy efficiency is where it makes sense the most. It's definitely a top product for us.
And we had the first federal LEED Platinum building anywhere. And we built a subsequent building, LEED Platinum, and then we went to this one, our largest, most challenging facility on the campus, and by gosh, we are going to make LEED Platinum, and they did. So the takeaway is, you're going to have to do it anyway, just do it right and save some energy.
Thanks again for joining us for this edition of B&G Solves It. As always, we look forward to bringing you more energy-efficient solutions, either through B&G Solves It videos or through your attendance at the Bell & Gossett Little Red Schoolhouse. Or an additional option, we now have the Bell & Gossett Little Red Schoolhouse online, where you can sample educational programs at your leisure.